Good morning, students. We are starting the third unit of the syllabus today. Okay. The third unit includes two chapters. In the first chapter, we learn about central processing unit. And in the second chapter, we learn about microprogrammed control. Okay. So unit 3, part 1 is central processing unit. In this chapter, we are going to discuss these topics. Okay. Introduction, general register organization, stack organization, then instruction formats, addressing mode, data transfer and manipulation, program control. All these topics, instruction formats, addressing modes, data transfer and manipulation. These topics have been introduced to you in the last chapter. Okay, but here we will learn all these topics in detail. Then program control, reduced instruction set, computer, RISC. Okay, these are all the topics we'll be covering in this chapter. Okay, central processing unit. So let's learn about the central processing unit. Okay, we know that central processing unit is the very important part of the computer that does processing, right? The major, the job that the computer does is execution of instructions. That is done in the central processing unit. So if you see the major components of central processing unit includes control unit, register set, and arithmetic and logic unit. Okay, so these are the three main components: control unit, register, set of registers, arithmetic and logic unit. Okay, and these all these functional units are connected using the bus. Okay, the data transfer between these happens through the bus. So register set, let's take this unit. Okay, the first part of this central processing unit, register set. This is used for storing the data, right? Generally, data is stored in memory, but why we need registers in the central processing unit? And accessing data from memory is the most time-taking job. Okay, in the computer, the most time-taking job is accessing data from memory. Okay, so to make it convenient to store the data, we use registers in the processor. If we have registers in the processor itself, okay, it would be more convenient to immediately access the data from the registers. Okay, that's the reason we have registers here in the central processing unit. Arithmetic and logic unit, it performs the required microoperations such as arithmetic and logic operations, and some cases shift operation is also included, okay, in the ALU. We call it as arithmetic, logic and shift unit. Okay, so it performs all these operations, arithmetic, logic and shift micro operations, to complete the process. And all these functions need to be controlled. So we have control unit. It controls the transfer of information between the registers, correct? And it instructs the ALU which operation to perform, okay, for getting the data, transferring the data from the registers to ALU for processing, and the process, okay, what is the operation that need to be performed. That is also instructed to ALU by the control unit. So if you see the components here, the storage components are registers and flip-flop. Okay, these are the components used for storing data. Okay, we have registers. The different registers are used to store different data. Okay, you know that we have learned about the basic registers available in computer: program counter, instruction register, data register, address register. Okay, all these registers are used for storing different data, and the size of these registers are different. And we have flip-flop. Flip-flops are single bit registers used to store a single bit of information. Okay, these are the components for storage. And execution component, we have for processing or execution of instructions, we have arithmetic and logic unit that performs arithmetic logical operations. And transfer component, for the transfer of data and signals between these functional units, we have bus, okay, that carries information. And the control component, okay, the fourth component is control component. it controls, okay, the entire operations of the central processing unit. So here it controls the transfer of information between the registers, and also the operation that is performed by the arithmetic and logic unit is controlled by the control unit. Okay, so if you take a computer, basic computer, the central processing unit, the design of the central processing unit is determined by these units, right? The registers. What all the registers available in the central processing unit of a computer. Okay, and what are the size of the registers? Okay, what are the different registers available? And what all the functions the arithmetic and logical unit perform? Okay, that also determine the design of a computer. Okay, so we are here learning about the CPU. So the design of the CPU is determined by all these components, the registers available, the number of registers available, and the number of operations the arithmetic and logic unit performs, and the number of the control functions used to control these operations. These determine the CPU design. Okay, we have learned about the components, major components of the central processing unit. The major components are the register, set of registers used to store data, and the arithmetic and logic unit used to perform the operations. Okay, used to execute the instructions and processing the data. For the control unit is to control the operations of arithmetic and logic unit and the transfer of information between the registers. So we have storage components and execution component, ALU as the execution or processing component, and bus as the transfer component, and control unit as the control component. So here we see the general register organization. We have the registers from R1 to R7. Okay, these are the registers from R1 to R7. We have 7 registers here. And the output of these registers are connected, okay, to the multiplexers. Okay, here we have 2 multiplexers. Let's name them as multiplexer A and multiplexer B. Okay, we have 2 multiplexers. And these multiplexers, the input to these multiplexers are these 7 registers. Okay, if you see, all the 7 registers are connected to the multiplexers as input. Multiplexer, you know what is the multiplexer, right? It is a circuit that takes many inputs and generates one output. Okay, so we have 7 registers, 1, 2, 3, 4, 5, 6, 7. And this is the 0th input to the multiplexer is the external input. Okay, external input is also applied to both these multiplexers, multiplexer A and B. That is input 0 to multiplexer. The multiplexer is 8 by 1 multiplexer. So it select one out of these 8 inputs and it generates a bus called A. Okay, this bus. The common bus A is generated, constructed by the multiplexer A. And multiplexer B takes 7 registers. The input to multiplexer B are the 7 registers R1 to R7 and the external input. Okay, external input is the input that is coming from the external source. Okay, from the input terminal. Okay, that is given by the user directly are applied to the multiplexers. So here the 0th input to multiplexer B is input, okay, external input, and all the other 7 registers are connected to this. Here this multiplexer, okay, selecting one out of these 8 inputs, it construct bus B. Common bus B is constructed by the multiplexer B. And ALU, here is ALU that performs the arithmetic and logical operations. So the input, okay, that is the output of this multiplexer, okay, one of the register, right? One of the registers or the input, external input. is selected, and that is given as first input to ALU. And the second input to this ALU is the content that is in the bus B. It may be one of the registers or the external input. And ALU performs the operations, okay, operation given, and it produces the output. That here we have external output. This output is external output. Directly this will be transferred to the external output device, okay. Or it can be, it is taken back to the registers, okay. This output will be stored in the registers. And how these operations are controlled, okay. What are the operations here being done? The multiplexer need to select one of these 7 registers and the input, and multiplexer B need to select one of the registers for the second input to the ALU, correct? Multiplexer A gives the first input to ALU for performing some operations on the data, and multiplexer B gives the second input, okay? So multiplexer E and B need to select one of those inputs, and ALU need to perform the operation. It has to select one of the operation, right, that need to be performed. And here, after processing, the output is given back to the registers, right, to store it back to the registers. Here we have decoder, okay, the combinational circuit decoder, that is to select one out of these registers, 7 registers, okay, to store the output. So we have the selection input. For the multiplexer A to select the input, we have SELA. What is this SELA? It is a selection input. It is a selection input, and SELB is the selection input to multiplexer B. And for ALU to perform the operation, okay, it has to select there, and the computer may perform many operations. So one of the operation need to be performed. That is controlled by, okay, the selection lines. We have 5 selection lines here, okay, that is named as OPR. OPR is the operation selector for the ALU. And after it ALU process the information, the output is given as the external output to the external source, or it may be taken back to the registers. It may be stored back in the registers. Here one of the register need to be selected, okay. So that is done by the decoder using the selection lines SELD, that is destination selection. Okay, we have 2 source registers. We need the 2 source registers need to be selected by multiplexer A and multiplexer B. Okay, for that we have selection inputs SELA and SELB, and ALU performs operation, okay, that is selected by the input, selection input OPR, and decoder selects the destination register, okay, using the selection input SELD. So we have the selection SELA, SELB, and then OPR, SELD. These are the selection input. This is to select one of the input to the ALU. Okay, for multiplexer A, this is applied to multiplexer A to select one among the registers. And SELB is applied to multiplexer B to select the second input to the ALU. Okay, it is applied to multiplexer B. And OPR is the selection input to ALU to select one of the operation. And SELD is the selection input to the decoder that select one of the destination register where the result will be stored. Okay, is this clear? The general register organization. The registers we have are R1 to R7, and these are applied to the multiplexers, multiplexer A and multiplexer B. Okay, multiplexer A, this multiplexer is a circuit that accepts many inputs and generate a single output. Okay, so if you see there are 8 inputs. Okay, 0th input is the external input. There is an external input that is coming from the input terminal, okay, from the user, and that is applied to this both the multiplexers A and B. That is the 0th input. And here this is R1, right? Register R1. So that is the first input, second, third, fourth, fifth, sixth, and 7. So this multiplexer A and multiplexer B need to select one of these registers, okay, or the input. Multiplexer A generates the common bus A. okay, and place the content of the register selected in the bus. And multiplexer B, select one of the registers, one of the input, and place the content in the bus B. And this, the content of A and B, bus A and B, will be given as the input to ALU. ALU perform the arithmetic and logical operations, okay, on the data, on the input data. And here to select the operations, okay, in the multiplexers, to select these registers, we have the selection input SEL-A applied to the multiplexer A, and SEL-B is the selection input to select one of the registers. Depending on these selection inputs, the registers or one of the register is selected, okay, one of the input will be selected. And we have for ALU to select one of the operation, the selection input is OPR, okay, and it performs the operation. ALU performs the operations on the data, input data, and it generates the output. The output generated can be either transmitted to the output terminal, or it has to be stored in the registers, one of the registers, okay, destination register. So here these register, one of destination register is selected by the decoder using the selection input SEL-D, okay. So if you take this example, R1 is R2 plus R3. The arithmetic operation performed is addition on the content of registers R2 and R3. So the first input to the arithmetic and logic unit should be R2, okay, and here this is register R2, and this multiplexer need to select the register, the content of R2, and place it on the bus. And the second input to the arithmetic and logic unit is R3, okay, register R3 here, okay, multiplexer B, select R3, the content of R3, and place it on to the bus, okay. So here we will have R3 as the second input to the ALU. Now what this ALU need to do, it has to perform addition. So this OPR, okay, select the operation addition, and ALU performs the operation R2 plus R3, okay, addition on the data in R2 and R3, and it generates the result. And here it has to be stored in register R1. We have the destination as R1, okay, destination register, where the result of R2 plus R3 gets stored as R1. Okay, so the result will be given back to the, placed on the output bus. Here is our out bus. Okay, so it carries the information, resultant information. And using the selection D, decoder has to select R1. Okay, so this particular register will be selected and the result will be placed in R1. So here multiplexer A selector is SEL-A. What this SEL-A does, this control select register R2, that is the first input, and place it in bus A. And multiplexer B selector SEL-B, okay, this select the second register, second input to ALU, that is R2, okay, register R3, and place it in the bus B. And the third step is the ALU need to perform the operation. So we have ALU selector OPR, correct, for selecting the operation. This select one of the operation, that is add here, okay. So it instruct through the control word, the control unit, through this control inputs, okay, selection input, it instruct the ALU to perform addition. The operator selected would be add here, okay. And then to store the result back in the destination register, we have the decoder selector called SEL-D, and that places that select register R1, and the output, content of output bus gets placed in the register R1. So here if you see the control inputs we have learned are SEL-A, SEL-B, OPR, and SEL-D. These all generated by the control unit, correct? The control unit controls all these operations of transfer of information from registers to ALU and from ALU back to the destination register, and also it controls the operation that is performed by the ALU. Okay, so all these selection inputs, SELA, SELB, OPR, and SELD are generated by the control unit. Okay, this way the control unit controls the operations of this computer. So here, what are the functions of control unit? Selecting the various components in the system, such as selecting the registers, okay, and selecting the function of ALU, selecting the operation. What is the function the ALU has to perform? And using this selection input, SELA, SELB, SELD, and OPR, the control word is formed. Okay, this is called a control word that has how many bits? This control word has 5 bits of OPR, right? Here OPR is the selection line to ALU that has 5 bits. So here this control word has the least significant 5 bits, that is OPR, and then SELD, destination selector, 3 bits, SELB, okay, the input register selector, SELB and SELA, each having 3 bits. So this is a 14-bit word. Let me check the attendance and come back. Yes, here the 14-bit, the 14-bit control word determines the operations, okay, that need to be performed by the ALU and the register transfer, okay, transfer of information between the registers. So if we see the register selection field, the register selection selection inputs are SELA and SELB, right? Input selectors. SELD is the output register. Okay, this select the output register, destination selector. And if we the binary code, okay, if we see, these all 3 bits, right? The selection A, SELA is of 3 bits, and SELB is the 3-bit word, okay, that is used to control the selection here. So it is 0, 0, 0, okay, and when it is 0, 0, 0, selection A input, okay, the multiplexer A select input. Okay, what is this? The external input, okay, that comes from the external input device. And multiplexer selector B, okay, SELB, that is the selection input to multiplexer B, will also be, it is 0, 0, 0, that time it select input. Okay, and selection D, select none, because, okay, only registers R1 to R7. In the next case, when it is 0, 0, 1, this selection A and B select register R1 and selection D select R1 here. And when it is 0, 1, 0, it's the register selected here by multiplexer A and B would be R2, and the decoder also select R2 as the destination register. And when the binary code of the selection input is 0, 1, 1, register R3 gets selected. When it is 100, the register selected would be R4, and 101, it is R5. Register R5, 110, R6, and when it is 111, the register R7 gets selected. Okay, so if you see this, and before that, let's also discuss this. Okay, so this is clear. The binary code, when the selection input, when these 3 bits are 000, okay, selection B, if it is 000, the registers it selectors, the input of the multiplexer selected is the 0th input, that is input. Okay, that is the external input. When it is 001, the register gets selected as R1. Okay, here is R1. Okay, so that is the first input to the multiplexer gets selected. Okay, bus B will carry R1 to ALU. And when it is 010 means it is 2. So the second input to the multiplexer, that is R2, register R2. And when it is 011, it is 3, R3. Okay, the third input will get selected, that is register R3. Same way here, multiplexer A. Okay, when it is 000, it is input 0, that is input. And here in the output side, okay, for the decoder, select one of these registers. Okay, there are only 7 registers, so it is from it the 001. When it is 001, R1 gets selected as the destination register. And when it is 010, it select R2, register R2, 011, R3, and so on. So this is how the register selection is done. And we have other operation. Another selection need to be done here is ALU need to select its operation. Correct? The operation that is need to be performed on the selected inputs. So that is decided by this. It is a 5-bit. What is OPR? Here it is controlled by the selection input OPR. It is a 5-bit word, right? Okay, the input has 5 bits. Okay, the operation is selected by this OPR input that has 5 bits. So the 5 bits, when it is 000, the operation selected is transfer. Okay, register transfer. Transfer the content of A. And it is the symbol used is TSFA. And when the 5 bits of OPR are 00001, the operation performed is increment A. And 00010, the operation is addition. Addition of, we need 2 inputs, A and B. Okay. And when it is 00111, the operation performed is A minus B, subtraction. And when the 5 bits are this, it is decrement. Okay. And then it is AND, the logical operation AND, then OR, we have XOR. The basic operations are given here: complement A, shift right A, and shift left A. Okay, when there are more operations included, okay, when the ALU can perform more operations, it is extended. After this 11001, okay, it defines some other operation. So here, let's say what the control word would be if we perform this particular operation. Okay, we have, let's see this example. R2 plus R3. Okay, add the content of register R2 and R3 and store it in register R1. So here, what this multiplexer A, the output of multiplexer A would be, yeah, what is selection input A? It is add R2 and R3. The register selected is need to be selected as R2 and SELA. Okay, what is SELA? SELA would be for selecting R2, it need to be 010. Okay, SELA, the selection input A will be 010 and SELB. So here when it is 010 SELA, it selects R2, okay, as the first input to the ALU. And what is SELB? SELB has to select the multiplexer B need to select the register R3. To select R3, okay, not this one, not here, R3, okay, for selecting register R3, the input SELB need to be 0, 1, 1. So it is 0, 1, 1. And now R3 is selected as the second input. ALU need to perform R2 plus R3. Okay, this is the operation ALU has to perform. So what is OPR? Okay, the 5 bits of OPR need to be, you need to refer this here, add operation. The operation performed is add. Okay, so it is 0, 0, 0, 1, 0. Okay, the 5 bits of OPR need to be 0, 0, 0, 1, 0. Okay, so here OPR input, the selection input to ALU 0, 0, 0, 1, 0. This is for addition. And ALU performs the operation and it gives a result. And it has to be placed back in register R1. Okay, our destination register here is R1. A selection input used to select R1, okay, is SELD. So the selection input SELD need to be 0, 0, 1. Okay, this frames our control word. Okay, how we write the control word? First part of the control word is selection A, second part of the control word is selection B, and the third part is selection D, and then OPR, the 5 bits of OPR, the 14 bits are framed. Okay, that controls this entire operation. Let's take another example. R1 is R2 minus R3. Okay, or let's take some other registers. What ma? How we write SELD as 001. SELD is, yeah, what is the destination register here? The example we have taken is this. Let me, what is the destination? It is R1. So what the destination, the decoder has to select register R1, right? Here from the destination registers for storing back the result, decoder has to select R1. That is controlled by SELD, the selection input D. And for selecting R1, you look at this table. For selecting this R1, this is SELD. Okay, what is the input? It has to be, the binary code should be 001 for selecting R1. When SELD is 001, it select R1. When it is 010, it select R2. Okay. Okay. You got it. Yes. So let's take this example. Let's say R2 is R4 minus R5. Okay. Now let us frame the control word, okay, for performing this operation. So what is our first input? Multiplexer A need to select, multiplexer A need to select R4 as the first input, and multiplexer B need to select R5. And this is controlled by selection input A, SELA. And multiplexer B, the selection of multiplexer B is controlled by SELD. And the result need to be stored back in R2. Okay, this is our destination register. This is done by the decoder. The selection of decoder is controlled by SELD, selection destination register selector. Okay, and the operation performed here is subtraction. Okay, the ALU has to perform subtraction on R4 and R5, and this is selected by the selection input OPR. Correct? Okay, these selection input SELD, SELA, and SEL, it is B. Okay, all these selection inputs are 3 bits. Okay, and here it is the 5 bit. The selection input is of 5 bits. So now what is SELA? For selecting R2, it is 0, 1, 0, 2, which is 2. the second input of multiplexer. Correct? The second input of multiplexer, that is register R, is it R2? Sorry, R4. What is SELA? Tell me. No, R4 is the S, 100, correct. It is, selection A should be 100, okay. And we are framing the control word, okay, which has the first part is selection A and selection B, selection destination and OPR. Okay, these are the four parts of the control word. So selection A is 100 because the register need to be selected as R4 in our here. The multiplexer input 4 need to be selected. This is R4. And the multiplexer B need to select R5, register the fifth input, that is R5. Okay, so for selecting the fifth input, selection B value need to be, what is selection B? It need to be 101, correct? And selection D has to, the destination register is R2 here. Okay, for selecting R2, SELD need to be 0, 1, 0, which is 2. And the operation that is need to be selected is subtraction. Okay, what is subtraction? What is OPR here for subtraction? It is 0, 0, 1, 0, 1. So OPR, selection input OPR would be 0, 0, 1, 0, 1. Okay, so this form the control word. Okay, selection A is 100 for performing this particular operation, R4 minus R5, and store it in R2. Destination is R2. For doing this operation, the control word that is framed is 100, 101, 010, 00, 101. Okay, so control unit controls the operations of the computer, the selection of registers here, and the selection of operation. Okay, that is done by these control inputs. We'll discuss here the microoperations for the CPU, and we will write the selection inputs and the control word here. If suppose the operation is, here is the microoperation, and selection A, selection B, D, OPR, and finally the control word. To understand this more clearly, if suppose the operation is R1 is R2 minus R3, subtraction we did. If it is R4 or R5, okay. So here the input registers are R4 and R5, and the destination register is R1. The operation performed is OR operation. Okay, so what is selection A? It is 100. For selecting register R4, it is 4. And it is R5. The second input is R5. So selection B is 101. Multiplexer B select R5. Okay, with the selection input, when the selection input is 101. And selection ACLD, okay, that the destination is R1 here. Okay, so selection input D need to be 001 to select the first register R1. And what is OPR? It is the operation performed as OR. Let's look at this OR operation. The OPR value was, binary value was 01010. Okay, 01010. So the control word framed is, first is selection A, then selection B, then selection D, then 01010 is the OPR. Okay, the 5 bits 3 bits, 3 and 3. Okay, so this is the control word that controls the operation of adding R4 and R5 and transferring it to R1. And if we take R6 is R6 plus 1. What is this operation? The input register is R6 and performing increment on R6, right? Just incrementing R6 by 1. So the selection input 1 is, yeah, instead of writing all here the control words, let's write here it is R4, selection B is R5, selection D, the input is the destination register is R1, and the operation performed is R. Okay, and the corresponding control bits are this. Okay, and here the input first register is R6, and we don't have the second register. It is in a single register, right? R6, and it is incrementing the register by 1, content of register by 1. So here there is no second input, and the destination is again R6. Okay, we store back the result in R6, and the operation performed is increment, INCA. Is it INCA? It is written as increment, INCA. Okay, we perform this operation. Here it is 0, 0, 0, 0, 1. So the OPR input is 0, 0, 0, 0, 1. And R6, to select R6, it is 1, 1, 0. This is ACLA. Okay, the first control word. And ACLB is here none. Okay, there is no second register, second input. So we replace this place. We write zeros. Okay, in this means the 0th input to the multiplexer is the direct input. Okay, let's say there is no input coming from external source. Okay, so it will not select it. It is here in the control word we write zeros. And selection D, SELD has to select R6 as the destination. So it is again 1, 1, 0. Okay, so this is a control word that controls the operation of incrementing the content of register R6. And if we take the operation of transferring the content of R6 to R7. So the input register here, first input is R6. There is no second input. Okay, it is performed on a single register, but we are transferring the result into R7. So R7 is our destination register. The operation is transfer, TSFA, correct? And what is R6? So ACLA, the input selection, okay, ACLA need to be, it is R6, 1, 1, 0, and there is no second input, 0, 0, 0. And the third selection input is, to select R7, it need to be 1, 1, 1. And TSFA, the code for this operation is, TSFA is 0, 0, 0, 0, all zeros. Okay, so this is a control word that performs, okay, allows the CPU to perform the operation of transferring information from R6 to register R7. And if it is, let's take some output and input. Okay, some operations that transfer the output to the external output and take input from external input. So if we take this operation, transfer the content of register R2 to the external output. So here our input is, first input is R2. And there is no second input. There is no second input. And the destination is output here, correct? This column is for selection D. Selection D is to select one of these registers from R1 to R7. Okay, decoder will not select any of the register, no register selection here. Okay, so it will be 0, 0, 0 for output. Okay, in the table we wrote, you can see here, when it is none, that means here it is output, because all the other cases we have all the 7 register. The selection of 7 register can be done, okay, when it is from 001 to 111. And when it is 000, it will not select one of the registers. So by default, it is the external output. Okay, so there is no SELD here. And the operation performed is transfer, correct? The same operation. So the first input, SELA, need to be 010, it is 2, R2. And there is no second register. And there is no selection D input. Okay, so that is also 000, so it goes to the output. And the operation for transfer is 00000. Okay, OPR control input will be all zeros. And if it is from input, if the input has to be directly transferred to the output, okay, the operation performed here is directly transfer the input to the external input to the external output. So here the selection is the first input to the ALU is input, and there is no second input here, and output, the CLD will not select any registers here, and the operation is again transfer, correct? Transfer. And to select input, SELA need to be 000, and there is no second input to ALU. And to select the external output, it is again 000, and transfer operation is selected by the OPR input, all zeros. Okay, so here the control word all zeros. What this does, what is the operation performed when the control word has all zeros? It just transfer the external input to output terminal. And let's try 2 more operations. R4 is shift left R4. Okay, so here the operation performed is shift left and the content of register R4. So input is R4. There is no second register here, and the register destination is R4. Okay, it has to be shifted left and transferred to R4. And the operation is SHL, shift left A, correct? SHLA. Okay, this is our operation, and it is 11000. So here OPR is 11000, and for selecting R4 as the first input, it is 100, and there is no selection input, second input, and R4 again, so it is 100. Selection D is 100. And one operation here, R5 is 0. Okay, means the content of R5 need to be cleared, right? Setting value 0 to R5 means clearing the content of R5. Okay, we have learned earlier in logical operations, content of register can be cleared by XORing the content, same content. Okay, if suppose R5 is 101, how will I clear the content of register? Okay, now take the content again. Okay, this is R5, and again this is R5 XOR this. Okay, perform XOR, exclusive OR on R5. So 1 and 1, when the bits are same, it gives 0. So you will have all zeros in the register. So the operation here performed would be exclusive OR on R5. So we have 2 inputs here. Even though the register is 1 and the input is, it is just transferring 0, means it is clear, it cannot be done this way. So we need to exclusive OR the content of R5. So the first input is R5, second input again is R5, and the destination is also R5. Okay, perform exclusive OR on R5 and store it in R5. So here the control word is 101, the first input, the second input is 101, and the destination is 101, and XOR. For performing XOR, the OPR is 01100, 01100. Okay, so this control word performs, okay, the operation of clearing the content of R5. Okay, so if you have any doubts, you can ask me in this topic. We'll go to the next topic in the next class. This is about general register organization. Understood, very good.